Hey, what's happening, guys? Welcome back to Raspberry Pi tutorial part 6. And in the last tutorial, we looked at getting around the file system on the Pi and the command line. And today we're going to expand on that a little bit more and cover some more advanced concepts and programs as well. So stay tuned. All right, well, I'm trying not to jump around too much and group concepts together so that they make sense. And I also want to give you a good solid foundation before moving on to more advanced things. So I'm going to get into editing and working with files in the next tutorial. But before we do that, we should cover some more command line stuff so that you have an understanding of other file system and command line interface concepts that we didn't get to last time. Last time we covered pwd, cd, ls, make directory, remove directory, and so forth. Mostly navigational type stuff. Anyway, let's jump right into it. Most of the commands that we've been talking about so far live in the /bin directory. And if you ever want to know where a program is actually located within the file system, just type where is and then the command name. So let's try that with, let's say cd. So let's where is cd. And in this case, cd does not actually return a directory where it lives because cd is built into the command line shell. So let's try something else. Let's try pwd. And we see here that pwd is actually in the /bin directory. So if you want to explore the bin or user/bin directories and see what commands are available to you, just type ls/bin or ls/user/bin. And if you want to know more about any of these commands listed, you can use man, and then let's say cd for this example, or man make directory, and then read about all of the available options. And when you're done, you can just use Q to exit back to the command line. And to scroll up and down to read more about these commands, just use your arrow keys up and down. Q or Control C will exit you from most commands in Unix, and you can also type --help after most commands on the command line to get brief usage help that's not as in-depth as the man page. You can still learn, quite a bit using the --help option, and that will vary depending on the program. Sometimes --help doesn't work. Maybe it's just a -h, or sometimes you could just type the command on the command line and it will tell you the usage without any options. So anyway, since we're going to eventually get into programming, let me talk a little bit more about running commands. All of these commands are accessible from any directory because of something that's called your path variable. And this is where is that we used earlier looks for those commands that we searched for. And what is your path variable? Well, a variable just stores a piece of information, and the system stores a bunch of these variables when you log in called environment variables. Your path is a listing of the directories where the commands, programs, or scripts, so forth, where they live and execute from. And to find out what these are, you can just type env to see your environment variable names and their current values. And as long as the commands that you want to run are located within your path, they will run. And if you want to run something that is not in your path, like say you're writing your own programs, you're going to need to tell the command line shell where to find it. And by the way, the command line is also known as a shell. So if you hear me talking about the shell, it's basically the same as me saying command line. Now, in the last tutorial, I mentioned that the directory above or behind your current directory was denoted by a ... and that the current directory is a single dot. Well, here's where we actually put that single dot to use. Let's say we have a directory in our home directory that's called code. We could denote that as ~/code, which is shorthand for home/pi/code. And you're writing your first program in a file called my first program. Well, anywhere outside of that home code directory, or even inside it for that matter, you would not be able to just type my first program to run it because code is not in your path. And the shell is not looking for runnable programs anywhere outside of that path variable. So you'll need to explicitly tell the shell that you mean to execute this file as a program with a dot and a slash preceding the name. And we're not going to get into scripting or programming just yet, so I'm trying not to jump ahead. But just as an example, I'm going to create a quick shell script program called My First Program. And I'm going to glaze over what I'm doing here, but don't worry, I'll cover this in a later tutorial when we actually get into some basic programming. So for now, you can just copy what I'm typing here and follow along if you want. So let's open up our My First Program, and I'm going to type a couple of commands here. And then echo hello world. This is my first program. And then I'm going to exit out with Control X, answer yes to save. And then I have to change the mode to 755, my first program. All right, so it's ready to run. So let's run this and see what happens. / my first program. And there we go. It says hello world. This is my first program. Let's try it just to illustrate my point without the /. All right, so as you can see from the code directory, if you type / my first program, and it will run. Without it, it will not. So if you are not in the code directory, you could also specify the entire directory path and run this file outside of that directory using /home /pi /code /my first program, or the shorthand version of your home folder, the ~/code /my first program. And any of those will work from anywhere outside of that code directory, but only / will work from within it. And I know I'm throwing a lot at you very quickly. I hope this makes sense for now and it didn't completely confuse you. So if you need me to clarify, just comment below. This might make a little more sense in just a moment when I talk a little bit more about how the path works. Okay, so let's backtrack just for a moment to the environment variables again. Any of these environment variables that were listed can also be accessed by using their name with a $sign in front of them. And the $sign just basically tells the system that we want to access the contents of the environment variable. For example, say we want to see what's in our path and not the rest of the environment variables. Just use the echo command and then $path, which will list the contents of the path variable. And without the $echo would just print the word path on the screen. And also remember that in any Linux or Unix system, that file case and spelling is important. So make sure that you type all caps for the variable name and not a lowercase or mixed case because that won't work. So let's just try quickly using echo with some other environment variables. So let's just try here echo $username, and we'll see that that's our username. We could also use the whoami command to find this information out. And also let's echo home, which shows our home /pi directory. And now that we know all that, let's say that we wanted to add our home /pi /code directory to our path so that any of the programs or scripts that we write in that directory will be accessible from anywhere else within the file system. So we'll first need to access our path variable, copy it back to itself, and then append our code directory onto the end of it like this. Export, and then path equals $path to get our current path directories, and then a : home /pi /code. Now, what does this do? Well, with the export command, we assign the current value of path back to itself, and then we append our code directory to the end using a : which is also called a delimiter in this case, to separate that new directory from the rest of the directory entries within the path. Now, if we type env again, we should see the home /pi /code directory has been added to our path, and we can run my first program from any directory on the system. And here's something else you should know. Let's say another directory in the path also has a file called my first program. Well, how does the system know which one of these to run since they have the same name? If there are two versions of my first program, the system will run the first one that it comes across in the directories listed in the path variable. It's just something to remember. Let me also say, it may seem like a time saver to just add dot to your path so that whatever directory you happen to be in at the time will be searched and your programs can run from anywhere. Don't do this. It's a security risk. And also when you log out and log back in, any of these changes that we made here will go away. In order to make the changes persistent across logins, we'll need to edit our user profile, which I'll actually cover in the next tutorial when we get to editing files. All right, but let's move on for now. And one of the commands that I typed above was chmod 755 my first program. And let me take a moment to try to explain what this does. Chmod stands for change mode, and this is basically letting you tell the system what type of read, write, and execute permissions to give to users, groups, or owners of the files and directories on the system. File permissions and ownership are an important multi-user system feature in Linux and Unix and any Unix-based system. And if you are only used to Windows or the Mac graphical user interfaces, this is probably a fresh new concept. But let's analyze the number 755 parameter that the chmod command is using here. Each digit represents a user permission. And the first digit, which is 7, is for the owner, which in this case is pi. And the second digit, 5, is for the group access. And the third 5 is for all other users on the system. So how did I decide to use 755 instead of any other combination of numbers? Well, read access is represented by the number 4. Write access is represented by a 2. And execute access here is represented by a 1. And since we wanted to run this program, we needed that 1 added in. And let's say I wanted to give read and write permission. We would add 4 and 2 together, and you would get 6. Read plus execute permission equals 5, and read plus write plus execute equals 7. So 755 essentially represents read, write, and execute for the owner of the file, and then read and execute for the group and all other users. Now, I'm going through this pretty quickly. I know it's kind of confusing if you've never seen this before and if you're completely new to the idea, but after a while you will get used to it, and if you're using any Unix-based system, it will come in very handy to know how this works. And if you want to read more about it, just search chmod on Wikipedia. They have a pretty extensive entry on the chmod command. Now, why did we go through all of that, and why does it really matter? Well, remember when you used ls-l to list the directory contents as a long list? You'll see that beside each file, there are a bunch of RWXs, and there are actually 3 sets of them, along with a username and a group name after that. And then after that section, there's the date and time that the file was last modified. Well, the sets of R, W, and X's show user and group permissions to the files and directory. And you'll also see a dash to show where a permission is not set. For example, let's look at my first program, which is set currently to -RWX R-X R-X. The first little section tells us that it's just a regular file and not a directory, the first dash that is. And then the first grouping of RWX is for the owner of the file, which is pi. And the second set of R-X is for the group access, in this case also pi. And the last grouping is for all other users on the system, which is R-X. So basically it has read and execute permission, but not write access for anybody but the owner. So we modified these permissions of my first program using 755, but there's also another way to do this if the numbers thing completely confuses you. But I actually like the numbers method because even though I understand this other method I'm about to show you, the naming convention that they chose kind of annoys me. We could have also used the following command: chmod u plus rwx, comma, go plus rx, and then my first program. Now this does the exact same thing as 755, but for some reason, the way the command is laid out here, the creators of chmod decided to use U for the file's owner and O for other users instead of the other way around, which to me would have made more sense. This always confused and annoyed me, so I actually prefer to use the number method for file permissions. But anyway, that's all the time I have right now for this tutorial. I hope you learned a few things, and I hope it wasn't too confusing. If it is, comment below. And also be aware that the things that I'm teaching you do not only apply to the Raspberry Pi. Once you know all of this stuff, you'll be able to use pretty much any Unix type system like BSD, Linux, Mac OS. And in the next tutorial, which I will hopefully be creating soon, we'll get into editing files and some other fun stuff. So thanks for watching, guys, and be sure to subscribe and keep learning.